Hi everyone, welcome guys. Please confirm once that whether am I audible to you or not. Hi, good evening Satna. Shillong, Satna, confirm guys. Okay. And what about you, Shillong? Okay, that's cool. Mark your attendance once, please. And tell me, have you revised the Vesper theory that we were discussing in the last class? I think we have discussed up to PCL 5 and now we have to start with n by 2 equal to 6. Okay. Hi, HS School, Naharlagan. Okay. So guys, I'm giving you a question. First of all, you have to draw the shape, tell me the hybridization. Okay. Question is PCl3. Draw the shape, determine the hybridization, and what would be the name of the shape. And yes, at the just end of the class in the last session, Shillong has asked a question, okay, that I just read at that time. Okay, today I'll discuss about that question as well. Okay. So be ready, Shillong. You have to answer that question. I mean, all of you can answer the question, but might be that question can be answered by the person who has put that question. That was quite different question over there. Tell me answer for this one. How many days you will take, guys? Shillong, I haven't got the answer yet. Naharlagan. Okay, Satna has given the answer. And what would be the hybridization for this one? Okay, let's start. Let's calculate n by 2. Central atom is phosphorus, so use its valence electrons, which is 5, plus number of atoms, which is 3 upon 2, which is 4. So hybridization would be sp3. If I have to draw the shape, I'll put the phosphorus at the center and I'll draw the 4 bonds. And after that, at the 4 positions, I'll put the atoms. Here we can see that there are only 3 atoms, so I can use only 3 positions. So 1, 2 and 3. And the remaining position where we can't put any atom will become the lone pair. Okay? And the name of the shape is trigonal pyramidal. Got it? Next. Or dear, I guess you were absent in the last class, Naharlagan. I have already discussed the whole table in the last class. Now guys, let's move on to the next case, which is n by 2 equal to 6. See, the situation would be like this. One second. Now guys, look at this. N by 2 represents the number of sigma bonds. Number of sigma bonds. The bonds in with green dash are axial positions, or we can say these are the axial bonds. Whereas in red are equatorial positions. Okay, here the rule says that equatorial positions will be filled first, then axial. Okay, here this rule we have to follow. Okay, just copy this one and then we'll discuss few examples based on this one. Copy. Okay, let's start. See, let's say suppose we have got Xz F4. Okay, first of all calculate the n by 2. Xenon has got 8 electrons plus 4 upon 2. It will comes out to be 6. So our first work is to just draw the 6 bonds like this, and after that put the 4 atoms, because we have 4 surrounding atoms here, 1, 2, 3 and 4. Rest 2 becomes will the lone pair. And I have told you to imagine the geometry, hide the lone pairs. If you hide the lone pairs, you will find out that it is a square. Okay, that's why its name is square planar. Got it? This is your square planar. Okay. Let's say suppose we have got Xz OF4. Okay. Again calculate n by 2. Central atom is xenon again, so I'll use the valence electron, plus 4 plus 0 by 2. I have already told you that whenever oxygen is not central atom over there, we can't use it in the n by 2 calculations. Okay, so here again I'll put the xenon at the center, draw the 6 bonds. Now start putting the similar atoms in the same positions, and then make one lone pair and one oxygen. Okay. In actual, there is actually double bond between oxygen and the xenon, but according to Vesper theory, that pi bond has no sense. Okay. Copy and confirm. Guys, copy and confirm. Guys, copy it and confirm. I'm not getting your question, Naharlagan. Can you please repeat? Shillong, have you copied that? Guys, I need one person on the system. Okay. Let's talk about n by 2 7. Only one case. Okay. Which is IF7. So calculate n by 2. This is 7 plus 7 by 2, which is 7. So put the iodine at the center and then draw 5 bonds like this and put fluorine at every position. Okay, and then rest 2 fluorines like this. This is your pentagonal bipyramidal. Hi, good evening, Itanagar. Dear, first of all, tell me, Laharnagan, were you present in the last class? Shillong, in most of the cases, always single atom would be the central atom, okay? And some other questions are there. For that, you just have to remember those species over there, okay? You can just remember them. No other idea over there. So, my dear Naharlagan, I have discussed about it in the last class, and there is a quite large topic, so even I can't recall that all the concept. So just go through the lecture once and then you will get to know that how we were doing that. Copied? Do this question. Draw the shape, hybridization. Draw the shape and tell me the hybridization of XeF2. Then NF3. Then SF2. Do these questions and tell me the answer. Attempt these questions and tell me the answer. Pentagonal bipyramidal. Look at the table. This is your pentagonal bipyramidal. Guys, attempt this quickly and tell me the answer. Yes, it is. Guys, refer the table, use the table. No. This time wrong, Naharlagan. Shillong, Satna and Itanagar. Guys, how many days you need to solve these questions? How many days you will take to solve these questions? Okay. No, Naharlagan. Second one is wrong, Itanagar. First and third are correct. See, here n by 2 would be 5, and whenever you will solve it, you will get it linear. Here n by 2 would be 4. So if you solve this, you will get pyramidal. Here n by 2 will be again 4, and on solving you will get it bent. Yes. Any doubt in these questions? If I talk about the hybridization, this is your sp3d, this is your sp3, and this one will also be sp3. So guys, that's all about the shape. Over. Let's move on. If anyone has got any confusion or doubt, you can please ask me. Quickly, reply. If you have any confusion or doubt, you can ask me right now. If not, then we can proceed. Shillong, Satna, Itanagar, Naharlagan. Guys, do you have any confusion or doubt? Okay. Okay, then let's move on. Bond parameters. Bond parameter means, guys, about a molecule compound with 3 elements. I'm not getting your question, Shilong. In total 3 elements or surrounded with 3 elements with central atom? Confirm once. Surrounded with 3 elements. There are many available examples. You can take NCl3. Even this one will have the same answer. You can copy this question. NCl3, even this one will have the same answer. Bond parameters. First is bond length. Guys, very important topic with respect to the examinations. Okay. Not like XZF4. We should have available examples as well, na? You can take this one then. SOCl2. Sulfur would be the surrounding element. Sorry, sulfur would be the central element. Got it? Now let's move on. Bond length. First of all, let's write its definition. Then we'll continue. I'll make you understand that how bond length will be affected by the different parameters. Okay, means how bond length is dependent on the certain specific properties like electronegativity, or we can say the nuclear charge, and so on. Okay. First of all, copy its definition. Then we'll proceed. The average distance between two, we can say between nucleus of two atoms. Okay. Let's say suppose we have got A and B. We have got A and B. Okay. So guys, this dash, or we can say this bond, represents the bond length. Okay. It might have such phase scenario. Look at this. This is the nucleus. This is the nucleus. So actually, this distance is nothing but what? Bond length. Look at this. This is your bond length. Okay. And remember, this is the average distance. Okay. This is your average distance. Now, what can I say? That bond length would be radius of A plus radius of B. Okay. Whereas RA covalent radius of A, whereas RB is covalent radius of B. Okay. Guys, first of all, copy this one. Copy this. Guys, you can mark it this one as a case 1. This is your case 1. Okay. And here we can say that when electronegativity difference is 0. Okay. You can copy this one, guys. You have to copy this one as well. You can mark this one as a headline. Hi, good evening, Kohima. Why are you late? Guys, confirm me, are you getting this? Any confusion or doubt regarding this one? Any confusion or doubt in this one? Okay. Now let's talk about the case 2. When electronegativity difference is not 0. Means we are talking about the electronegativity of the atom A and atom B. Okay. In that case, bond length would be RA plus RB minus 0.09 XA minus XP angstrom. This is the second formula. Guys, these are the just formulas. Okay, you can just remember these formulas. Not so important. Examiner won't ask you that you have to determine the bond length over there. Okay, but yes, you can remember this formula just for the concept clarification, and as well, whenever hard time comes, you will find such questions. Oh, nice. So you have a meeting with Abhishek sir? Yeah, I'm telling you, dear, what is XA and XP. XA is electronegativity of atom A, and XB is electronegativity of atom B. Copy. Guys, these are the just formulas that you have to remember. And then ultimately the most important section is now we have to cover, from where you will have the questions in the exams. First of all, guys, everyone confirm that, are you clear with the bond length? See, bond length is nothing but it is the average distance between the two nucleus. Okay. It mainly depends on the electronegativity. It has two possible cases. First case, where electronegativity between the two atoms is 0. In that case, the bond length will be simply the sum of radius of two atoms. If there is an electronegativity difference between A and B, in that case, the bond length would be sum of the covalent radius, which is Ra plus Rb, minus a factor, which is 0.09 into Xa minus Xb. Okay? This is the whole summary till now. Okay, let's move on. Factors affecting bond length. First is electronegativity. Means electronegativity difference. Okay. Guys, first of all, look at the screen. I'm asking you something. First of all, tell me that, and after that, I'll discuss about it, that how it will affect. Okay. Just look at the two scenarios. This is the first scenario. AB. Do not copy this. And this is AC. See, this dash is actually representing the bond length. Okay. Right now I'm saying they both are look like this. Okay. I said electronegativity of B is greater than C. I hope so. I have already discussed with you what is the meaning of electronegativity. It is nothing but tendency to pull the electrons towards itself. Okay. Now I'm saying the initial scenario was this one, but when I have got knowledge about the electronegativity here, remember one thing, that A is definitely less electronegative than B and C. Okay, A is less electronegative than B and C. So obviously A can't pull the electrons, but yes, B and C will pull the electrons of A towards themselves. Now I said after pulling the electron, this electron shifted here in A, and now the current scenario is this one. Whereas in case of C, it won't pull the electrons much. Okay, and it look like this. Look at the two scenario. Look at the two scenario, and tell me. This is your D1 and this is your D2. What do you think? Which one should have the greater value, D1 or D2? For the better clarification, you can do this one. You can draw it here. Yeah. Tell me. Which one is greater, D1 or D2? I'm repeating question. Look at the two dots. The two dots are representing the bond length, which is D1 and D2. Look at the screen carefully and tell me which one should have the bigger value, D1 or D2. Okay. Okay. Shillong, look at the screen carefully. Okay. Obviously, guys, D1 will have the smaller value and D2 will have the bigger value. Because B had pulled the electrons of A towards itself more forcefully. That's why the bond length, which is this one initially, now becomes this one. Here, this one was here in initial, and now it is shifted to here. So obviously, D2 is relatively bigger in the distance, or we can say bigger in the length. Okay, so D2 is the bigger value and D1 is the smaller value. Now you tell me, what do you have understand? If electronegativity is high, then its bond length should be what? High or low? Means big or small? My question is, if electronegativity is high, then what should be the bond length? It should be larger or smaller? Okay, yeah, very good. So guys, this is the concept actually. If you have understand this, it means it's over. Now we have to just write it. Look at this. We can say bond length is inversely proportional to the difference in electronegativity. I hope so everyone is getting this. Okay. So guys, we can take an example that HF, HCl, HBr and HI. Arrange them in the order of increasing bond length. Arrange them in the order of increasing bond length. I hope so everyone has attempted that. Just confirm me that, do I have written the right answer? Is it the right answer? Okay. Guys, check out and tell me, do I have written the right answer? Why? This is a bond length order, guys. Okay, it means that we haven't got anything. Means we haven't got nothing. First of all, just tell me, hydrogen is same in every atom. Fluorine, chlorine, bromine and iodine. Which one has the highest electronegativity? Fluorine or iodine? Obviously, you have learned that fluorine has got the highest electronegative element in the periodic table. So this is the order of electronegativity. So higher is the electronegativity, means what? Lower should be bond length. So fluorine has got the highest electronegativity, therefore the atom attached to it will have the smallest bond length. So that's why this order is absolutely correct. Koima, have you got that? Okay. Okay, let's move on. Next is bond order, or we can say number of bonds. Number of bonds. Simply remember, guys, bond order is inversely proportional to the bond length. Higher is the bond order, smallest will be the bond length. Okay, so just look at this: C single bond C, C double bond C, and C triple bond C. Okay, if I talk about the bond length, its bond length is 1.54 angstrom, 1.34 angstrom, and this one is 1.20 angstrom. Okay, see, number of bonds between two atoms are increasing, that's why bond length is decreasing. You can simply remember this one. Okay, just copy this. After that, I am giving you a question, and you have to arrange them in the order of increasing bond length. Copied. Okay. Tell me, what should be the bond length order for these three species? Mark them as a ABC. A, B, and C. Tell me the order. And after that, this is the question number 1, this is question number 2. A, B, C, and D. Arrange them as well. Arrange them as well. Shillong, I haven't got answer from you. Itanagar as well. Naharlagun, very good. Okay, nice Kohima. Nice Shillong. Obviously, this is the order. And here, A would be greater than B and C, and D would be smallest. Okay, Itanagar. Dear, what's the problem? Please tell me. See, I was just telling bond order. Bond order means number of bonds. See here, only one bond is present. Here, two bonds are present, and here, three bonds are present. Okay. If number of bonds are increased, it means bond length will decrease. See, one bond is there, so it has got highest bond length among these three. Here, number of bonds get increased. See, they are inversely proportional. It means if one value is increased, other one will decrease. See, bond length is decreased. Now, number of bonds are again increasing. It means bond length will again decrease. Okay, so nothing but If number of bonds are increasing, bond length will get decreased over there. Now get it? Now attempt this question. Itanagar, confirm. Okay. Next. This was bond order. Part third is hybridization. Guys, look at this very carefully. Very carefully. First of all, understand this one, that bond length is inversely proportional to S character. This is, you have to remember. Now the next important thing, S character is actually proportional to electronegativity. Okay? Now, remember one thing. S character increases, electronegativity will also increase. Okay? I'll tell you that how we will determine the S character. Look at this. Let's say suppose we have got sp3. I am determining the S character. So guys, in the sp3, you can check out there is only one s orbital, whereas 3 p orbitals. In total, we have got the 4 orbitals. Now, I have to determine the s character, means percentage. So I'll put the number of orbitals of the s in the numerator part upon total into 100. You will get 25%. Check out sp2. 1 by 3 into 100, which is 33.3%. In case of sp, it is 1 upon 1 by 2 into 100, which is 50%. Okay? It means that sp3 has got the least S character. It means this one will have the least electronegativity, whereas sp has got the highest S character. That's why this one will have the highest electronegativity. Confirm me, guys. Clear to you? Is it clear to you? Everything which is written to you on the screen? Confirm once. S character is nothing but, dear, it is the amount of S, mean percentage of the S orbital in the total. It means that ultimately we are determining the electronegativity, nothing else. Okay? Now guys, I have a question for you. Just look at the screen and tell me. There is a bond which is found by sp3, and there is a bond which is, do not copy this, which is found by sp2. Tell me, this is A and this is B. Which one will have the higher value, A or B? Means A and B are the bond lengths. A is found by the sp3 overlapping, and B is found by the sp2 overlapping. Tell me, which one should have the higher value? Rate with the electronegativity. Higher value. Okay, 2 I've given the answer. Itanagar has changed his answer. Shillong, Naharlagun, Satna. Okay. Kohima, look at this. I said AB and this is your CD. Okay. I'm saying the electronegativity of AB is less than CD. Now this is A and this is B. This is the electronegativity. Now tell me what is your answer? Which value should be bigger, A or B? Shillong, I haven't got your answer. Yes. We have to determine which one will have the higher bond length. Kohima and Shillong, tell me. Exactly. What do you say, Kohima? Do you have any confusion? Dear, you can just ask me. Guys, I am repeating again that if you have got any confusion or doubt, please say straightforward, sir, that I haven't got that. If you waste your time, I'll ask you 5 times, dear, is it clear to you, clear to you? Then you're wasting the time. After that, you will say, no, I haven't got that. Or might be you won't share that, you haven't got that. So, dear, this is disastrous actually. We are here to learn something. And I expect that in the every class, whatever we discussed is clear to everyone with a zero doubt. And you're always free to ask doubts, guys. Don't feel shy to ask the doubts. See, if you won't ask or clear your doubts, then this class has no sense. See, we have discussed that higher is the electronegativity, lower should be the bond length. So, sp2 has higher electronegativity than the sp3. That's why bond length, this is the electronegativity, I have just discussed about it. And bond length will be what? Reverse. Okay, that's what I have just discussed with you. See, look at these orders. Look at this. And look at this one. Okay. I'm writing some standard results. Okay. Need not to remember those bond lengths. Just we have to make confirm that these are the bond lengths. Okay. Just copy with me. Just copy with me. Compounds, hybridization, and here we have got the bond length. Ethane. Hybridization is sp3 sp3. Bond length is 1.54 angstrom. My dear, do not remember these data. Okay. If you can remember, that's really good. If you don't want to, don't memorize this data because they won't give you any significant positive outcome for this one. Okay. Positive as in the examination, they won't ask you what is the bond length of the 2 carbons in the ethane. Okay, need not to remember that. But yes, you should remember the concept that what will happen with the change of the hybridization. Okay. Now, look at this. sp3 and sp2. This one will become 1.51 angstrom. sp3 sp 1.47 angstrom. sp2 sp2 1.46 angstrom. Dear, you can remember that here these marked carbons are actually determining the hybridization. Means this sp3 is written for this one, and here this sp2 is written for this one. Similarly here sp3 because of this carbon and sp because of this carbon. Here this is your sp2 and this one is also sp2. You can pick out any one. Okay, copy please and confirm. Just copy that and confirm this. Shillong, Satna, Naharlagan, Kohima. Guys, have you copied that? Okay. Let's continue. This is your sp2 and sp hybridization. Bond length is 1.42 angstrom. Last case is your sp-sp. .37 angstrom. I'm giving you a question. Not always true sp2 for the double bond. Yes, there is a concept that how to determine the hybridization. I'll discuss about it in the hybridization section. Don't worry for that. Check out the bond order. Oh, sorry, bond length. Tell me the answer. Kohima, are you there? Are you still there? I hope so there is no network issue. Arrange the following in the order of increasing bond lengths. Okay. We have got one answer. Kohima, tell me the answer. Okay, nice. Itanagar, you haven't put the symbols as in uh, greater than or equal to sign. I mean greater than or less than sign. Kohima, what's your answer? It's okay, dear. Just do that. Yeah, I'm sure. Definitely I can scroll up. See. Okay. I think A and B are also there. Kohima, you have written 3 times C. Okay. Where is the symbols of greater than or less than? Okay. Chat system error. Fine. No issues. Look at this. C, A, B. This is the answer. Yeah, you have done the right answer. Any confusion or doubt? Anyone, guys? Anything that you want to ask me? Please go ahead. That's all about your bond length. Next, we are going to discuss about the bond angle. Next topic. Just confirm me once. Okay. Okay. Now, Shillong, you can tell me the answer of your question that you have put it at the last in the last class. See, if this was nice, I mean to say, if this one will be nice, then I'll share with everyone. I have read your question. Even I have clicked that as well. Okay, you were saying in the last class as well, sir, would you like to hear a joke? Yes, I'm ready for that. After that joke, I'll start with the next topic. Please go ahead. Actually, you have got a point. Even you have also got a point. Okay. Nice one. Okay, guys, so let's start with the new topic. Okay. By the way, what's your name? Bond angle. Okay. Okay, so guys, let's start with the bond angle. Okay. And before that, okay, dang. Okay, so before that, I'll tell you something about the students. Okay, there are 3 types of student. I mean, that's what I can observe. So after today, whenever I'll ask you, after discussing the concept, so I'll ask you that in which category you are right now. So you have to simply say that A, B or C. Okay. You have to remember the choices A, B, and C. Okay? This for everyone. C. Let's do it like this. This is A, this is B, and this is C. See, whenever a teacher teaches to you something, let's take an example that I am telling you something. Okay, I am giving you a concept. Okay, so there are three possibilities of that. Okay, I'll say something that student even won't listen to that, and they will reflect that. Means they won't even allow the words to just get into enter your ears. Okay, this is a type A student. Okay, and you might get all three types of students in a single class. That's the interesting thing. Okay, type 2. They will listen to you. The concept will enter from the one ear and it will pass away from the other ear. Means there's a person sitting in front of us is saying something, but we will hear that and we will just pass through with the other ear, because God has given us 2 ears. Okay, and there is type C persons. They will listen to you and it will get enter here. Okay, means they will listen you, they will understand the meaning, and they will make sure that after completion of that particular topic, everything is getting clear to you. Okay, so there are mainly three categories, A, B, and C. So guys, whenever I ask you about the, after discussion of the concept, that which category in right now you are, so you can simply say A, B, or C. Okay, I hope so you have understand the meaning of A, B, and C. Have you got that? Confirm once. Okay, let's move on. And if you find any other fourth category, you can please tell me, because I have observed up to means till now only these three categories. Okay, and I think where is the fifth one? Okay, I'll discuss about that. Number 2, which is bond angle. Dear, bond angle is nothing but it is the angle between the two bonds. Look at this. See, this is known as the bond angle. Okay, so I can simply define it. The minimum angle between any two adjacent bonds. Okay, simple definition of the bond angle. Just copy this and then again the important factors that can affect the bond angle. Okay, copy this. Let's move on, guys. Factors affecting bond angle. First is hybridization or S character. You can simply check out that bond angle is directly proportional to the S character. Copy this first. I am giving you 3 species: BeCl2, BCl3 and CCl4. Quickly tell me hybridization. Hybridization of these species. Determine the hybridization of BeCl2, BCl3 and the CCl4. You can write in the sequence. Will you say something, guys? Do you have any point? Shillong, do you have any point? Okay, nice, Itanagar. Satna, Kohima, Shillong, Naharlagan. Guys, have you got the answer? I have told you n by 2 method. Use that method, na? Use that method and then tell me the answer. Very disappointing, guys. Very disappointing. Only Itanagar has given the answer. Other than that, Shillong, Satna, Kohima, Naharlagan, no one has written their answer. SP, SP2 and SP3. We know that hybridization or its character exactly are same. So you can check out. This one has 180 degree angle. This one is 120 degree angle. And this one is 109 degree 27 minutes. Okay, so we can simply say that BeCl2 has got highest bond angle, then BCl3 and then CCl4. Copy. Point number 2, central atom. See, bond angle is directly proportional to electronegativity of central atom. Okay, how? Check out this one. This is C, this is B. I am saying electronegativity of A is greater than C. So what will happen? That A will pull the electrons of B towards itself, like this. Okay. See, A and C, between A and C, A has got the higher electronegativity, whereas B has lower electronegativity as compared to A and C. Okay. So obviously C will again pull the electrons towards itself, like this. But here the problem is, guys, see, here the electrons comes much more closer. So that's why they will repel more. Whereas here, look at this. Here, they won't repel much because they are not actually very much closer to each other. Okay. Therefore, if electronegativity of central atom is high, it means that it will pull the electrons towards itself, and whenever it will pull the electron towards itself, whenever they will come in contact, not contact, whenever they will come in closer to each other, they will repel with the strong force and bond angle will get increased. Look at this like this. See, see these are the two bonds, first bond, second bond. If electronegativity of these two bonds are higher, it means they will tend to go away from each other. And look at this, this bond angle is increased. See, this bond angle is increased. Now, if I say that the electronegativity is less, means that electron pairs won't come closer to each other. So definitely they will repel each other, but not with the significant repulsive force. So they will repel, but slightly. But they will repel the slightly. That's why what will happen? The bond angle will be low. So here I can say that this is, let's say suppose theta 1 and this is theta 2. So I can say that theta 1 would be greater than theta 2. This is the concept. Now tell me, in which state you are right now? A, B or C? Okay, just tell me, have you got that? Okay, that's good, Sapna. What about you guys? That's really bad, Naharlagan. Okay, what about you, Shillong? Itanagar? I'm giving you a question. Please tell me the answer. See, nice one, Shillong. Nice one. Tell me, this is your theta 1, this is your theta 2. see, after reading that statement, it reminds me of PG. Okay, I'll tell you about that PG. Guys, just tell me the answer, then after that I'll tell you a joke. Don't expect that is a very good one, but yeah, just after reading a statement from one center, I got strike that joke. Just first of all, tell me the answer. How many days you will take to answer this question, guys? Shillong, Itanagar, Naharlagun, Satna. 1. Okay. Wow. Kohima, what do you say? What's your answer? Shillong. There's a very lazy person on the system in the Shillong center. Yeah, much better. Obviously, this one will have the higher value. Why? Because electronegativity of oxygen is greater than sulfur. Okay, electronegativity of oxygen is greater than sulfur. Now do this question. NH3, PH3, ASH3. Arrange the following in the order of increasing. Arrange the following in the order of increasing bond angle. Tell me the answer. Mark them ABC. Mark them as a ABC. This is A, this is B, and this is C. Tell me the answer. And I need answer from every center this time. Shillong, Satna, Itanagar, Kohima, Naharlagun. If you want to answer this question, सबको पाप लगेगा then. Okay. Who is present at the Satna center? Shillong, Itanagar, Kohima. I haven't got your answer yet. Okay, good. Yes guys, you can check out electronegativity. Nitrogen is greater than phosphorus than arsenic. Okay, hydrogen has got the same electronegativity because same as in all three compounds. So we know that the higher is the electronegativity, higher is the bond angle. So ammonia will have the higher, then pH3, then ASH3. You can say A, B or C. Okay, this is the order. We have to discuss few more important factors on which bond angle depends. Okay, so guys, let's wind up today's session. Okay, please revise it again, and if you find any difficulty or you have got any question, you can please ask me in the beginning of the next class, or you're free to ask your doubts on the groups as well. Okay, but yes, do perform well in your examinations. Okay, make feel proud for everyone. Okay. Oh, my joke. Yeah. Oh, let me tell you a joke, guys. Listen, this is a PG. Don't expect this is a very good joke, but yeah, you might laugh on this one. One day, what happened? A person was sitting on a beach, and he saw that a person jumps into the sea, and he never comes back. Okay. So that happened on a day. Again, he was sitting on the same beach and he saw that again a person goes into the sea and again that person never comes back. So that person got confused what's actually going on over there. The two person goes into the sea and they never comes back. Then he was thinking about that, and after some time he again go to that beach and he saw that again a person goes into that sea and again that person never comes back. Then he clicked the idea. Then he write a book and said that man is soluble in water. Have you got that? I told you don't expect a lot in this joke. Okay, so this is a kind of PJ. Okay. So guys, man is soluble in water, remember that. Okay, so you can also get your own theories. Okay. So guys, let's wind up today's session. So that's it for today's session, guys. Thank you so much. See you next time, guys. Till then, take care. Bye-bye. Good night. Stay healthy. Take care of yourself. Okay. Bye-bye. And thank you so much.